In this video, I am going to solve this Bernoulli differential equation. As you probably know, a Bernoulli differential equation has the following format: dy over dx plus p of x times y is equal to q of x times y to the power n, where n cannot be equal to 0 or 1. If n is 0, then the equation becomes a first-order linear differential equation that can be solved by integrating factor. If n is 1, it becomes a separable equation. In our particular example here, n is the power of y, which is 1/2. So we'll go ahead and solve these differential equations. The first step is to divide both sides of this equation by square root of y. Okay, so that's going to give me 1 over square root of y dy over dx plus 3 over x times y divided by square root of y is just square root of y is equal to 1. Now I'm going to make a little substitution, and that substitution is going to be this. It is going to be this as z. So my z is equal to y to the power 1/2 or square root of y. So that will give me dz over dx is equal to 1/2 times y to the power 1/2 minus 1, which is negative 1/2, times dy over dx. So let's simplify it a little further. If I do that, I get 2 times dz over dx is equal to 1 over square root of y, which is just y to the power negative 1, times dy over dx. Now notice that this is nothing but this, which must be equal to this. So there is going to be 2 dz over dx. Now if I substitute these values, I get 2 dz over dx plus 3 over x times z is equal to 1. Now this is nothing but a first-order linear differential equation that we could solve by using integrating factor. But before that, let me just simplify it a little bit. I'm gonna go ahead and divide both sides of this equation by 2, and that's gonna give me dz over dx plus 3 over 2 times 1 over x times z is equal to 1/2. Now this is a first order linear differential equation that I could solve by using integrating factor. Okay, so my mu of x integrating factor is equal to e to the power integral p of x dx, which is, by the way, going to be just this number. That's going to be e to the power integral 3 over 2 times 1 over x dx. That's going to give me e to the power 3 over 2 ln of x, or e to the power ln of x 3 over 2. In going from here to here, I use this formula, which is n ln of x is equal to ln of x to the power n. So remember that. But ln and exponential, they're inverses of each other. That will leave me behind with mu of x is equal to x to the power 3 over 2. Now I'm going to go ahead and multiply both sides of this equation by mu of x, which is x to the power 3/2 or 3 over 2. That's going to give me x to the power 3 over 2 times dz over dx plus 3 over 2x times z times x to the power 3 over 2 is equal to 1/2 times x to the power 3 over 2. Now if I simplify it, this is what I'm going to get. X to the power 3 over 2 dz over dx plus, I kind of don't need to simplify it, but I know what I'd get, but let me go ahead and do it. So this is going to be 3 over 2 times x to the power 1 half, because x to the power 3 half divided by x is x to the power 1 half, times z is equal to x to the power 3 over 2 over 2. Now the left hand side, the effect of multiplying by the mu of x, it makes it a derivative of two numbers or two functions in this case. So this is going to be d over dx x to the power 3 over 2 times z. Okay, and that is going to be equal to 1 half times x to the power 3 over 2. Now I can go ahead and take the integral of both sides with respect to x dx. Integral of both sides with respect to x. Now on the left hand side, I'm going to get z times x to the power 3 over 2. And on the right hand side is going to be 1 half times x to the power 3 over 2 plus 1 divided by 3 over 2 plus 1 plus some arbitrary constant c. Let me simplify it further. Z times x to the power 3 over 2 is equal to 1 half times, this becomes just 5 over 2, or equivalently 2 over 5 here if you flip it, times x to the power 5 over 2, because if you add 1 with 3 over 2, that's going to give you 5 over 2 plus some arbitrary constant c. So that's going to give me z times x to the power 3 over 2 is equal to, these 2 and 2 cancel out, that's going to give me x to the power 1/5 times x to the power 5 over 2, right, plus some constant c. Now if I multiply both sides of this equation by x to the power -3 over 2, so x to the power -3 over 2, why am I doing it? So that I can get rid of it. That's going to give me z is equal to 1/5 times x to the power -3 over 2 times x to the power 5 over 2 is going to give you x to the power 2 over 2. That's going to be just x plus c times x to the power -3 over 2. However, z is nothing but square root of y, right? So it's going to be square root of y is equal to 1/5 x plus c times x to the power -3 over 2. Or if I solve for y, it's going to be y is equal to y of x, which is going to be equal to, put a square bracket for clarity here, 1/5 x plus c times x to the power -3 over 2, all of it square. And this, by the way, is going to be the solution to the differential equation, which is this. I hope that this discussion was helpful. Thank you very much.